Okay, this is from section 8.1 of your book, Direct and Inverse Variation. We've actually been doing direct variation since Algebra 1. Any equation of the form y equals a constant times x is a linear relationship, and it's also called direct variation. So you're familiar with that. You've been doing it for a while. Inverse variation is when we start to get into the rational function family. The form for inverse variation is y equals a constant, a, divided by x. So you can see now that x is in the denominator, and that will greatly change the shape of the graph. And you'll get to see that in the assignment. So direct means that as x increases, y increases, whereas inverse, as x gets bigger, y gets smaller in general. So let's do some examples here. If we're given an equation, let's determine the type of variation. So it's going to be either, your answers will be either direct, inverse, or neither. So first example, let's say we have 3x equals y. Well, we can just write that in the other, just switch the sides, y equals 3x, and that's direct variation. Y equals a constant times x. In fact, y is 3 times as big as x. Let's try this. Let's say we have xy equals 0.75. So every time we multiply x and y together, we get the same answer. That's a sign that it's inverse variation. But to put it in the form so you can see it, all you have to do is divide both sides by x. So we divide both sides by x, and you get 0.75 over x. And now it's in that form, so this is inverse variation. And just to be complete, let's say we had an example like this. Y equals x minus 5. Well, this is neither. It doesn't fit either form. You're not multiplying by a constant. You're not doing a constant over x, so you would just say neither. Okay, now let's look at some word problems here. So let's say we have an example like this. The width of a rectangle, W varies inversely with the length L. Okay, so that's telling you the relationship between the width and the length. The width of a rectangle W varies inversely with the length L. Next, if the length is 2, the width is 18. So you have to be given some kind of information so that you'll be able to solve for the constant. And then you'll often be told to find something, like find the width when length is 18. When the length is 18. Find the width when the length is 18. Okay, so there's 3 parts to doing all of these problems. And the first part is to write the equation. Given the relationship, write your equation. So it says that it varies inversely. So the width varies inversely. You know it's W equals a constant over L. That's the first step, to show that you know it's an inverse relationship. The second step is to actually find the constant. In this case, we're using variable a for the constant. sorry, the constant, the letter A for the constant. So you plug in what's given, the 2 and the 18. So when the width is 18, 18 equals A over 2, because the length L is 2. We're told that in this sentence. To solve for A, you simply multiply both sides by 2, so A equals 36. And then you rewrite the equation with that constant, so width equals 36 over L. So there's our new equation with the constant solved for, and then finally step 3 is to use your equation to get whatever information you want. And you'll see some interesting examples in the book. So if L equals 18, that's what we're told, we want to find the width. So you just plug it in. Width equals 36 over 18, which equals 2. And so that is the way that you do all of these kinds of problems.